Welcome to qnawire.
Problem 11.25. So we have a 2-meter long steel wire. The diameter here is probably not to scale. We're told that the maximum amount is allowed to stretch with a 700 Newton tensile force applied to it is 1/4 of a centimeter. And so the minimum diameter of the wire can be to make sure that this is the maximum amount it will stretch. So we start off with the expression for the Young's modulus. So the strain divided by, the stress divided by the strain. And now we know that the area is the area is pi times the radius squared. And the radius is obviously half the diameter. So we solve this for the area we need. And so then that's L naught F divided by the Young's modulus times the change in length. So the Young's modulus for steel is about 200 gigapascals. And something interesting is that although there's a huge number of different types of steel and different sort of hardening treatments that can be applied to them and things like this, but it turns out that the Young's modulus, regardless of composition or heat treatment of the steel, they're all around 200 gigapascals. So that's a convenient thing to know if you ever, if you're doing things with calculating stuff that involves the mechanical properties of steel. You can find this in table 11.1 in the book. So putting these numbers in, the area will be 2.8 times 10 to the negative 6th meters squared. Now the area is pi r squared. So the radius is the square root of a over pi. And the radius is going to be 9.44 times 10 to the negative 4th meters. Oh, it's worth noting that if we put the maximum value of delta L in here, because this is in the numerator, that will give us the minimum diameter of A. Because if, we have the maximum, but it's inverted, it will give us the minimum we need for this. And then so the diameter is just twice this. And so it's 1.9 times 10 to the negative 3rd meters, or about 2 millimeters. So you can see that this is grossly not to scale because, 1.9, millimeters. You can see this is grossly not to scale because The aspect ratio of this should be 1,000 to 1, just about, but that's difficult to draw.